take time out of your day to join us today. So, yeah, would you like to just introduce yourselves firstly, and then
yeah, certainly. So I'm Andy from Herschel. Have this peculiar title, Director of Renewables Integration. I come from solar background, and so over the last sort of 7-ish years, Herschel has been very much working, obviously, in terms of our core technology, but also in terms of the roadmap to net zero, how we work with primarily renewable technology. So I bring the solar background to the infrared. And my interest, I guess, in infrared started from the profile of solar is a technology that's relatively simple to design and install, has ultra low maintenance, servicing requirements, and a long operational lifespan. That's directly transferable to infrared heating. So they're highly complementary technologies. So that's sort of what I take care of with Herschel.
Thanks, Andy. Yeah, thanks for having me along today. My name is Matt Dodds. I'm the commercial team here at Herschel. I've been involved just over 8 years. Background in commercial property and asset management. What twigged my interest was looking at the management and costs of various projects in terms of electric heating on student property. And then it's sort of linked in with conversations I was having here with Herschel and knowing the CEO, Paul, who said, look, we've got this new opportunity to bring infrared heating to a wider market, both commercially and domestically, and I'd like you to lead it. So that's where I've been. And as things are progressing in terms of decarbonising heating, moving across to efficient forms of electric heating and looking at the options within a wide range of different building types. So we will get involved with specifying churches at one end and looking at particular heat sites of that, and industrial units across to passive houses, low energy houses as well. So I'm responsible for the overall specifying of that with our team.
Cool. Cheers, guys. No, welcome indeed. Matt, if you obviously drive your presentation, if you just let me know as and when direct me.
I'll pick up here. The idea of this is really just to introduce infrared heating as a concept. We'll assume people have a level of awareness that it's out there, but maybe not a deep understanding of how it works. So we're going to very much work with plain English. We don't want to bombard you with the physics. There's a 3-hour lecture if you want to get into sort of the high-end stuff, but this is really to introduce the concept and get you all comfortable with the technology as what we would describe as one of the best and most affordable routes to, if not net zero, certainly an ultra low carbon sort of heat and power system. So in terms of infrared, this is direct radiated heat. So if you bear in mind, almost all heating systems work by convection, which warms air, and yet air temperature has relatively little to do with comfort and rather more to do with the temperature of the walls, the floors and the ceilings and the spaces that we occupy. So because we're heating surfaces and not large volumes of air, we generally use less electricity or energy to achieve comfort. Thereafter, those warmed surfaces lose heat at a much slower rate than air, and so less energy is consumed to maintain comfort thereafter. And that's why it makes it such a potent technology. So we're essentially directly warming surfaces and people rather than the air, which readily escapes. And there are different wavelengths. So there's 3 main categories for infrared, and we operate with all 3, albeit, I guess, with a fairly strong focus, particularly within the residential space, in terms of what we call far infrared. So far infrared is long wave. There's no visible light, so all of the electricity conversion is turned into heat with sort of 100+ rate of efficiency. There's also a medium range, which is quite useful for outdoor areas, but also for hard to heat internal spaces. And then there's also the short wave. People are generally more familiar with short wave infrared from things like outdoor sort of bar and smoking areas. Short wave, if you're not careful, can be quite unpleasant both to look at and it's very intense. So a lot of what we do is primarily in far and long wave, second in the medium wave with some short wave for those particularly hard to heat applications. And one of the things that we do try to articulate is the whole concept of improved comfort. And it's not an easy thing to sort of describe. It's more based on basically living with the technology and feeling it. But the improved comfort comes from the fact that surfaces are slightly warmer than if you're trying to heat by air. And I guess the reason that is so important is if you walk into a space and feel cold, it's actually because you are radiating your stored thermal mass to the environment. So what we're doing is reversing that relationship. So essentially the space becomes a 360-degree radiator.
And Simon, sorry to cut in, Andy, if you click the button, I think there might be a graphic that comes up on that slide.
There is, yes.
Hopefully. Yeah. So there we go. So that's what I think. Yeah.
So that's sort of demonstrating the concept that at a lower air temperature, you can achieve high levels of comfort if the surfaces are warmed. Infrared is also a very innovative solution in that if you take the example of, say, a bathroom, you will usually need a mirror and a heat source. So you can combine the two in an infrared heated mirror. So it's quite an interesting technology, and it has this sort of bi-functionality. If we could have the next slide, please, Simon. And this, as an energy hierarchy, won't be new to any practitioners, but it's something that we do sort of focus on. So obviously good design is all about designing out the demand for energy, and in this case heat, from the building through good insulation, good construction standards, good glazing, etc. Thereafter, we should look at using energy more efficiently, and that's really the space that we occupy, pillar 2 of this hierarchy. And if you've designed out as much of the demand for heat that you can, you then need to select a technology that's going to operate very efficiently within that lower demand. And that's where infrared has a really, really strong and potentially scalable role to play. Thereafter, add renewable sources to generate your own clean electricity alongside a clean electricity grid. Albeit we have this hierarchy of 1, 2, and 3. There's an awful lot of focus on just doing the renewables because solar especially just makes so much economic sense at the moment. But in an ideal world, we would basically follow this hierarchy of design out the demand for heat, then use technology that uses energy very efficiently to provide comfort, and then provide energy from renewable energy sources and a clean electricity grid thereafter. If I hand over to Matt now for a few comments on the next slide.
So we introduced the technology to the UK about 12 or 13 years ago. And I think as infrared is becoming more popular and recognised, we've got to be quite clear what we define as being infrared heating, because there's a lot out there in the press at the moment with different technologies. And I think concern I have is that consumers and specifiers are getting confused by what classifies it as infrared and what doesn't. Now, the radiant heating is heat generated by radiation. As you'll know, infrared is the type of radiation used by the heater to directly transmit that heat from the surface of the heater to the environment around it. And that's important because there are set international standards, which are EN standards, for direct acting room heaters. And most critically, it includes measurement of the percentage radiance that infrared heaters have got to have to qualify. If they don't hit the criteria, they don't comply with that standard. So the standard is clear that any heat emitting surface with a surface temperature of less than 40 degrees centigrade cannot be classified as a radiant heater and won't be considered at all. At this level, the radiant output is less than 40%. And the result is the vast majority of heat will be from convection and not from infrared. So a heater surface of below 40 degrees centigrade doesn't have enough of a temperature difference between the heater itself and the materials it's trying to heat to be classed as a radiant heater. And that's important. So the standard will say heaters offering a surface temperature between 40 to 200 degrees centigrade may classify, but critically the heaters have got to have a radiant efficiency over 40% to be considered. So I'm getting slightly into the technicalities of it, but it's important in terms of what is recognised internationally and by BASE actually DESNES as they're dabbing.
So from that perspective, then, what should we be looking out for if products are claiming?
So we are members of the European Infrared Alliance, and they are, again, where the technology originated from, but they're driving the standards as well, and we are carrying out further testing of our heaters. But if you can see a temperature of a surface temperature of a heater over 75 degrees centigrade, which ours are, they can immediately be classified as radiant, because they've got a high enough temperature gap between the heater and the surfaces it's warming, and it's radiant and not convective heat transfer. So our heaters, certainly the panel heaters, will be around 70% radiant and the rest convective. So there's not going to be 100% radiant, but you've got to be clear on that radiant output to be classified. And my concern over the past 12 to 18 months has been, I think certain parts of the heating industry have jumped on that infrared word as part of their marketing, and where they may be providing good benefit for heating environments, we've got to be quite clear what the principal type of heat coming from these heaters is, and the materials they're using, to be classified principally as infrared and not convection-based heating systems. So there will be, I would imagine, the next 6 to 9 months standards similar to what you'll see on electrical appliances like fridges and freezers, and there will be a sticker type arrangement where it will be very clear on saying the percentage, it's been tested to this standard, and this is the percentage radiant output for this appliance, and that's where it's moving to. So that's what I'll be looking out for. So our surface temperature of our panel heaters are upwards of 95 degrees centigrade to 100 degrees, and they're sized correctly to give the right wattage output for that surface area of the heater. So we know we're falling into the category to correctly be classified as infrared heaters. So BEIS, as was in their cost optimal electrification reports, have said that the infrared heaters that they are defining have to have a radiant fractional percentage of 70% or more. And then the infrared group of in Europe, their infrared manufacturers are saying the surface temperature has got to be a minimum of 75 degrees centigrade. So yeah, we're very closely aligned with those European testing standards, and got colleagues over there as part of that group and leading that with them. And I think we've just got to be we've got to be clear on that surface temperature to give us the benefit, and anything less has got to be looked at. But I think Julian's come in with a question, is that right at the bottom there, saying, yeah, the surface temperature is 75 degrees centigrade or more, but we are able to touch the heaters because that heat energy is spread across the surface area of the heater on the majority of our panels, which means you can touch it, but not hold your hand there for too long. And it's the equivalent to a wet radiator on full, or the top of a convector grill, which actually has got a higher density. Okay. But yeah, again, as with any heat type, not recommending holding your hand there for long periods, but the benefit of infrared and where we want to be mounting them is higher up on walls at picture height, or ceiling mounted ideally, to get space back in the room, and it gives a little bit of an additional efficiency in heat output from ceiling mounted position. Okay, moving on to this slide. So this is a summary of the first independent testing of infrared heating that's been carried out in the UK. So this was at Salford Energy House 1. So that tested our premium range of infrared panels against an air-to-water heat pump and a standard electric convector heater. So following SAT schedules and hours, and over the identical test conditions, which was the average temperature of a UK heating season plus 4.7 degrees centigrade, these are the efficiency results that came through. So as expected, the heat pump was providing an efficiency 173%. The standard electric convectors were in at 100, and our infrared heaters were at 113% as the efficiency. Now that is because of the way we're warming the mass and objects in the space, and being able to lower the temperature on the thermostat by between 1 degree and 1.5 degrees, and still having the same level of comfort. So we'll come on a little bit later about the controls and how important that is in the whole system and running of our infrared heaters. But that was the reason why you're getting those additional efficiencies. And actually, moving forward with this next range of testing we're doing with Salford, we're going to be changing a little bit about the way we are setting those thermostat temperatures in those rooms. The main difference that came out of the testing when we were comparing CapEx costs between the systems, I'm looking at the heat pump and our system, that what came through was the high cost. It was around £12,000 for the installed heat pump system and £4,000 for our infrared heaters. And this is on a 2-bed Victorian terrace, so supply and install. But that doesn't include any grant monies from the boiler upgrade scheme. But there's still a big differential between the two systems. And again, you'll know heat pumps have got their place. We're working with a lot of people on hybrid schemes. So some people that might look at a heat pump on the ground floor and then infrared heating on the upper floors. But it's the suitability in a Victorian terrace arrangement like they've got in Salford and what's going to work in different environments. So I think current policy needs looking at, because there is no one-stop silver bullet solution for heating these environments. And with the additional cost of CapEx for that heat pump, we're saying, look, consider infrared, invest the additional saving in upgrading your fabric performance, and look at solar PV and batteries as well. So that's where we've come out of on that test.
I guess the key headline comment there is infrared is absolutely zero maintenance.
Yeah.
So there's no ongoing service, parts replacement, etc. And it's very important that we look at the total cost of ownership throughout sort of a technology's lifespan. So yes, there's certainly a capital cost advantage at the front end. There's also an installation cost advantage because you're just using standard electrical trades. There's nothing peculiar about infrared. If you can basically put lighting circuits together, you can put heating circuits for infrared together. It's just different loads, fusing, etc. But basically all of the cost is at the front end, and those costs are very competitive with all of the alternatives.
Okay. Julian, sorry to see you raise your hand.
Yeah, sorry, I couldn't find how to switch on the hand on
I never know either.
That doesn't, you're comparing 173% air source heat pump efficiency, which doesn't seem very good, since I get 370% efficiency with mine.
Well, this is the independent testing that's been done by Salford. So, and that's at the point that the heat pump was coming in. So that's over an identical period with that measurement. So whether there's the way they've set it up or it's been installed, I think they knew what they were doing to do that, but that's the figures that we've extrapolated and they provided from those independent tests. So there's a longer summary on our website actually that you can have a look at in terms of the overall costs, and there's more to come out in terms of occupier comfort side and some of the more of the black bulb readings that they've got on their test rigs in those rooms.
Okay. And how would infrared be over 100% efficient?
Well, in terms of the running hours against electric convector, so we're showing additional efficiencies over that by the way we're directly heating the mass and objects, and that's storing heat, and we're needing heating to be on for less time in comparison because of less time and because of the level of temperature we're able to get to with the same level of comfort for a slightly lower temperature on the thermostat. So it was a kilowatt hour comparison.
But okay, I was measuring air source heat pump efficiency is measured on energy put in compared to energy delivered.
Yeah.
Are you saying that you're putting 1 kilowatt hour in and getting 1.13 kilowatt hours of heat out?
Well, it's on that comparison of the running hours efficiency. So in terms of, I think it was 20,000 kilowatt hours for the convector, but we were about 17.7 as in kilowatt hours for the infrared, and the heat pump being a lot lower than that. So it was on the kilowatt hours across the period of testing. That's where you're seeing additional efficiencies in the way we're heating at the lower temperature.
Okay, I don't understand that. I'll have to read the report then.
It's worth checking out. So there's some information on the website, Julian, but please note this is not our data. So we basically supplied the equipment in, The university did their test in basically a very much a sort of standardized like-for-like model. So all we're doing is reporting on the data, and they came at this as very much technology agnostic. And the whole idea of the Salford House is replicating a heating season. So within this chamber, they can, whether it's wind, external temperature, snow, rain, they're able to model all of so they basically took essentially what is a typical heating season, but this is very much their data. It's very helpful for us, but this is not our marketing department creating a story.
No.
Okay.
But it's the way we're heating with that, the infrared heaters that we've got in terms of building up the temperature in those environments, and that storing the heat and being a different way of heating those spaces compared to convection. That's where you're getting the additional efficiency.
Yeah, I think where Julian's coming from is because it is normally how much energy is input, and then what's being delivered is the common way that the heat pump guys measure efficiency. It might be something we pick up with the guys from Salford as well, because we try and get William Swan back in. But yeah, as suggested, Julian, with your brains, it would be good to read the paper and feedback once we upload the video. Angus has asked a question, Matt, as well, regarding issues with increased loads.
Yeah. So it's not been something domestically we've had big issues with. I mean, it's been more commercially, actually, a lot of environments where they've been heating with gas. But no, I see that. I mean, in terms of the heaters and wattage that we're putting in, we are typically, I mean, it depends on the environment, going to be looking at between 15 and 20% less wattage compared to standard convector heaters in terms of loads. And then I think my understanding of lots of the installers are making calculations on a diversity factor and the way we're heating individual spaces in those rooms without assuming that they're all on at the same time. So there might be a percentage less than that. So no, it's not been raised as a substantial issue. It's been more on commercial sites or churches where they've been shifting from oil or gas-based heating systems and had to shift across and look at upgrading supplies, the distribution companies.
Okay, thank you. Richard, did you want to come off mute? Saw you raised your hand. Perhaps you didn't. I thought you did.
Yeah, hi there. Can you hear me okay?
Yeah, we can.
Yeah,
hi, Richard.
Yeah, when you do infrared heating, it's on off, isn't it? So obviously if I'm occupying the room and I walk in, I want it to be warmed up. But as soon as I walk out, you can turn it off. And I think if I'm getting my head right, this is where you get the efficiencies. Air source heat pumps 24/7, infrared, on off. As you go into a room for maybe half an hour, you're heating the room for half an hour, not 24.
No, you're right. And that's just, we are getting away from a central heating system and a central control system. So where we are getting additional efficiencies, you're right, it's on controls in individual rooms. We are building up the thermal mass and then maintaining the temperature. So you might have a lower setback at, say, 14 degrees when you're not in there, and then programming it to come on to preheat you in a bedroom for the time you want to go to bed at a slightly higher temperature. So it is additional efficiencies across those rooms and the whole house from having rooms at different temperatures at different times. And certainly, during COVID periods where people have been just using heaters in their offices to heat them, they've been able to turn the rest of their heating systems off. So I think the big distinction we want to make, though, is lots of people are expecting the panel heaters to perform in a similar way to walking outside to an outdoor bar or restaurant with a stronger wavelength of heater. With the panels, in a well-insulated space, the warm-up times are obviously going to be lower, but we are wanting to build up the temperature of that thermal mass. We don't want it off and cold and then expecting a very fast reacting system. We're needing to maintain the heat in the fabric of the property. That's key. And that has a big impact then on the levels of comfort, but also the savings. We're able to control different rooms at different temperatures.
That's fine. You answered my question, I think. Thank you.
Cheers, Richard.
Okay. Richard, I think there's a question coming there. So the air source heat pump is based on wet fed radiators on that question, Richard? So air to water heat pump.
Do you want to come off mute again, Richard?
Yeah, sorry, I was just, the reason for the question was that if it was the likes of obviously underfloor heating or radiant panels, then the radiant fraction would be higher, and similarly then the, you know, the if you like, the heat maintained in the room by objects and mass would be similar to that with infrared. You know, using radiators, I wouldn't say is particularly a fair comparison.
Yeah, well, this is so these are wet fed radiators for vessel heat pump. That's what's being compared in that environment. So what we are working on with, we were on a call yesterday, Andy and I, with so we've got a new heat loss modeling tool that we've been working on. But again, within that model, you are having applied to it an improved efficiency using infrared in the way we're heating the spaces, but also there will be reduced impact of ventilation losses. So it's principally more on transmission losses, and the temperature differential between other heated spaces and the rooms we are heating is lower because of the way we're heating. So it links in with the test we've done and the lower air temperature or temperature reading on the thermostat to give these levels of efficiency from this testing.
Out of interest, is there anyone on the call that has infrared heating at home? If so, raise your hand. I'm just interested to learn, because, you know, I think this, when we were introducing this webinar on meshwork, you know, education in this area is clearly key, because it's getting people to think about, you know, how infrared works differently to standard central heating, albeit there's a bit of a, you know, air source heat pumps, not necessarily standard central heating technology either, but it's it's interesting to see how, like, how many controls, where are the controls, how do you have the controls? Because, you know, from a behavioral change perspective, if you are walking into a room that is cold and you are then relying, I get it, you know, because it seems sensible and efficient to only heat the space that you're in, but what people are used to with gas boiled central heating is the whole house is warm at some point. Whether that's right or wrong, that's just what people are used to. So there's behavioral change required. To how many controls do you need? Is there an app? Can you do it from one place? How many panels do you need in a room as well?
Yeah, so so there is an app. So we use the Smart Life app, which is a third-party app that deals with a number of different devices. So you can control that once you've set up your Wi-Fi network from your phone, or quite often we're recommending a centrally mounted tablet in a hallway, and then maybe a first floor landing if you wanted to control the different devices from that. And you can share that amongst your family and have a number of different routers and different buildings on your same app as well. So if you had, you know, some people coming in with holiday homes or wanting to manage their parents' property or whatever it is, they can do it that way. The number of panels will depend on the overall calculation of heat loss and how you're getting there, which we've got our own calculator for. And I was just touching on before that we've developed this other infrared heating tool, part of this other heat loss calculator that we've been working on. So that analysis is key. The amount of glass you've got in there, level of insulation and standard construction is key to your overall heat losses. And then you're looking, because it's on the light spectrum in the way these heaters are projecting, you've got to think of it like a lighting layout in terms of positioning. And I saw a question pop up about mass and objects there. So what I don't want to be seeing is anything shoved low down in a room to replace where a storage heater might be with a sofa pushed up against it. The whole of the face of these heaters are going to be projecting to the room to warm the mass and objects in it. And ceiling mounted is a good position to have them in. It gives you the space back, but also means it's giving you an opportunity to heat the mass and space below it. You will get a direct feeling of radiant from the panels within 2.5 to 3 meters, as us being an object in that room in front of the heaters. We, in the COP26 house up in Glasgow, for example, the Home for the Future, where we went in, passive house, timber frame construction, we were mounting our panels up about 4.5 meters on the slope of that pitched roof and getting really good benefits lower down. But it will come down to your air tightness, your overall level of insulation, and other factors to determine how much wattage you're putting into these spaces.
Thank you. Cheers. You've just covered some of those questions, but it might be worth, there are a few now, might be worth just covering them off from the top. Paul's talking about replacing his oil heating system with IR panels.
Actually, sorry, I'm going to come back on a question which I saw pop up a minute ago, actually, I think was on, or was it Edward that was asking about the fact that heaters are either on or off. I think that may be one of his questions, which is right. We are in development with another couple of products, which I can't say a huge amount about, but that may move forward where there may be variable power output from the panels. So that's something that we are, in development with, and hopefully we'll push forward with quite quickly. But that would mean, in theory, and we've been testing it here, that you would have full output from possibly 2 elements within the panel, and then you can go to a lower setback on part of the heater and one of the elements to provide a sort of an underlying level of heat, just as a gentle top up without it being on or off completely. So that's to be provided more information in due course. But something that's been looked at.
Cool, thank you. Paul, did you want to come off mute? Just talk about your particular scenario.
Can you hear me?
Yeah.
Excellent. Yeah. We're hopefully going to get planning permission through this week to put a big extension on our house to get my parents in with us.
Yeah.
And tied in with all that, I want to try and sort all our, get rid of the existing boiler and put infrared panels in to heat the rooms. Now, initially I was thinking, could I get away with not putting that in all the rooms? So perhaps put it into the wet rooms.
Yeah.
And let the MVHR that we're going to put in take that, because that will be drawing heat from the kitchen and the bathrooms, and then redistribute that. But is that really the way it's going to work with infrared panels? I could imagine it working well with a radiator.
Yeah.
Well,
so we can be looked at as a full solution. We can also be looked at as a top-up solution for other heating systems if we need to. But one of the key points with customers coming into our showroom that we're stressing, and this is where I think sometimes the capital cost and disruption of some of the heat pump systems, I'm just picking them out at the moment, is putting them off. Some saying they can't fund that cost up front. Now, and they're looking at ways of phasing a change in heating over time. And if they wanted to retain a gas combi boiler, which I've done in my property, but I've actually isolated 2 radiators, capped them off in the kitchen. I've done a kitchen diner knock through and put infrared heaters in there. So people can phase it over time as the position changes and the legislation changes towards fossil fuel heating. And you can look at it room by room. You can also look at it obviously with the rooms where you might be having benefit from MVHR or not, but absolutely you can phase it. And that's what I'm suggesting doing in quite a lot of environments, that if people want to experience it and get there before committing to a whole house retrofit with infrared or a combination, then get it in 2 or 3 rooms, start with that and make sure they're comfortable with the way it works for them.
Yeah, that sounds quite good. Do your systems integrate? Well, will I get them integrated into Home Assistant?
So we're working, so Google, we've got Alexa and then Google Home and with Smart Life uses but some of the other automations with Smart Life, it just depends what you can do with that and what the links are. But certainly at Google you can. And
because we'll be putting sensors in all the rooms, and it'll be, if I can detect whether there's people in there and what the actual temperature is, whether we need to turn the heaters on or not.
So what's quite interesting with Smart Life and what we've set up and I've got at home, you can set scenes and automations on there and tap to run functions on the thermostat settings. So we've combined them in the office here with PIR sensors. So you can have if and when statements within the settings for thermostats. The mean, as I'm sat in this meeting room here, when I come in, the temperature on the heat will go up to a certain level. When it doesn't sense movement in a certain period, it would go down to a setback temperature. And that's the next stage, I think, for a lot of people to look at, quite simply, and we're trying to get that message across through videos and other training we're doing, that's the way to set it up in their home environments to get better efficiency out of their system.
Yeah, that's great.
Cool, thank you. Should we,
Next slide, I think, for
Yeah,
me.
yeah, no, I'm just conscious of the time. It's great we're having lots of questions. It's fantastic we're having lots of questions, because I just want to come on to sort of how it works with the other renewable technology as well, and especially like when it comes to heating water. So let's crack on.
So this is a summary of some modelling we've had carried out by SAP Assessor, quite local to us, in a typical 3-bed new build property. Now, yeah, as you'll be aware, for a lot of you, you can see that significant difference in CO2 emissions between infrared and the gas and the air source heat pump. But to get your rating up to a high enough level to pass, you're needing to put in PV and a combination of solar PV and batteries in certain instances to hit that target. Now I'm doing quite a lot of work, the lobbying side, and speaking to, so at Salford, obviously the government have done some of their own testing on infrared, and there's a stage 2 trial that's now underway, being led by Leeds Beckett University, looking at different types of technologies in that Salford Energy House environment, and also testing infrared heaters of different types. And that's going to lead, I think, in the next 3 or 4 months to confirm going to a larger home trial with occupiers. So that's where it's going to go as the next stage. And my understanding is that the intention will be that infrared heating will form part of a separate category in the next iteration of SAP 11, to coincide with the future home standards in 2025. So that's what the guys at DESNZ are saying, but it's the speed of doing it for us. And just looking at these figures on their own, what you'll be aware of in the way that the SAP software works, the thing that penalises us significantly is the fact that we are classified as direct acting electric heating, and that primary energy factor that is applied for electric heating penalises the overall result. And I think that's what we're pushing to get reviewed and looked at in more detail.
And another just comment, if you look at the sizing of the solar, obviously to get the equivalent C band, there's a lot more solar, and yet the size of the solar array partnered with infrared is rather more appropriate for a modern home when we're looking at full electrification of heat, power and transport. Another key headline as a metric to bear in mind, the capital cost at the front end of whole house infrared plus circa 5 kilowatts of solar is very similar to just the air source heat pump before you add the 2 kilowatts of solar. And we're actually starting to see a similar capital cost heat pump with whole house infrared plus 5 kilowatts of solar plus 5 kilowatt hours of battery. And I guess in terms of some of the messaging we have with not so much the volume house builders, particularly the regional ones who are just a bit more, say, receptive to exploring alternatives, the end product is far easier to live with because you're generating more of your own electricity with a heating system that requires zero maintenance. So the end product pitched to the market is just more attractive. I mean, it's early days. Obviously, Future Homes is going, so there's going to be a level of PV required anyway. But I don't see this larger requirement for solar as a disadvantage. Rather, I would argue you end up with a whole house system for heat and power that's just better in the long term. In a couple of weeks, we'll be discussing solar again, some of the challenges of roof integrated versus roof applied. But I actually think it's quite encouraging if you move towards bigger solar rather than these notional new builds with 1.5, 2.5, maybe 3 kilowatts integrated in the middle of the roof, with then relatively limited opportunities to expand the system thereafter.
Cool. Cheers, Andy. Shall I move on to slide, Matt?
Yeah, if you could, please. It's probably back to Andy.
Yeah.
So.
So yeah, I guess there's not a lot of information here. It's just really to highlight the real importance of control, and essentially we are very modular. So controls are very much on a per room basis. I mean, that's the case with any heating system. All heating systems should have control, but the level of granularity that we can achieve is quite unique because it's radiant and we're working with warm surfaces rather than sort of air. So obviously there's a range of thermostats. What a key point I would always make is where convection and radiant are quite different is you tend to find convection is kind of a straight line. You put a unit of energy in to achieve a unit of increase in temperature, and it's pretty much a straight line. Radiant heating is a little bit different. So if you're from a very cold start in sort of 5 degrees, you will have relatively more energy put in before you get an incremental increase in temperature. But then you find you hit this very sort of steep curve whereby relatively less energy is required to keep raising the temperature. So when we talk about setback temperatures, it's really important to sort of think of sort of 14, maybe 15 degrees as a setback temperature, because it just means that when you do need comfort, infrared has less work to do than convection to get you to sort of your notional 21 degrees, albeit based on end user feedback, an awful lot of people are quite comfortable at 19 to 20 degrees when a conventional system would be at 21 to 22, even in the depths of winter, because of the whole concept of heated surfaces versus heating air. And that's again where some of the running cost efficiency comes from, controlling each room and then essentially minimizing the demand for heat on a per room basis by just sort of taking the temperature down half a degree every week until you've got to the minimum temperature that you're still comfortable. And there is a slide coming up where I'll sort of share a bit of end user feedback on that. But I say controls are very important, and it's just as important with us as any other heating system, but absolutely key.
So just on that, and I'm just going to add that we were approached by a lady called Alison Kidd, who is a behavioural psychologist, and she has approached. She said, "Look, I'd like to speak to some of your customers. Would you reach agreement with them for me to interview them about their experiences with infrared and how they're controlling it?" And I think what gets lost a lot of the time in some of the analysis of heating and specifications is that occupier comfort side. So there is a report summary on our website again, where it's very interesting the feedback we're getting from people about. Some of them are fixed on using thermostat controls, others are using portable heaters much more locally to where they're sitting and turning the rest of the heating system off. The feedback is very positive overall, but the different ways people are approaching using the heaters was the thing that came back from that report. But it's getting a greater understanding and pushing that occupier comfort side, because I think that gets lost quite a lot of the time.
Yeah, I get it. It's all about, I mean, it's not all about comfort is clearly key, as well as reducing the amount of emissions, etc. But I mean, I cannot envisage just moving a portable heater around. That's not practical, is it?
No,
that is a secondary. Okay.
It is. Well, yeah, some of them have got them sitting close to where they are and standing close on feet close to where they are, and they do have inbuilt thermostats or can be paired to a thermostat to comply with Lot 20 guidelines and regulations, so that's not an issue. But it's not, quite often it's topping up an existing heating system in a certain room if they're feeling it's not enough, but quite often they are using it as a sole solution, so it isn't just a secondary heating solution.
Okay. Stephen and Alex is a passive house consultant. Stephen's asked a question here regarding any issues using this system in a passive house with regard to compliance with their strict criteria.
No, not that I'm aware of, no. So we've been doing work recently with BT Passive, actually, over in Norwich. And they've got a few larger schemes that we're involved in over in South Wales, and they've had our heaters and been testing those and seeing how that fits overall with MVHR. That's one of the main reasons they system. But no, from a compliance perspective, I'm not aware of any. No.
Cool. And I'm not sure if we referenced Alex's question regarding where the panels are facing, and are they able to warm all areas of the wall sufficiently to prevent corners falling below the dew point?
Positioned correctly, yes, it can do. I think it's what's happening in those corners, because you're going to get conduction when some of the spaces are warm, the surfaces are warmed, it will be conducted across those surfaces. Yeah, if you've got a particularly difficult damp space and you're putting a load of furniture into the corner of that space to block it, so I mean that may be an area that you need to look at in more detail. But no, it's the balance of temperature. That's one of the key bits of feedback we get from people using the heaters.
Okay, cool. Thank you. I'll just move on a slide. I'm conscious we've 10 minutes to go and lots of questions coming in. So
yeah, so is that back to you, Matt, just for some sort of general headlines in terms of I guess what this slide is basically just some of the key headlines. So it's practical in terms of relatively simple to install with minimal disruption in both retrofit and new build, cost effective in terms of capital costs, running costs, and zero maintenance thereafter. And obviously there's the commercial and industrial work, which isn't really the focus of today, but it's certainly a big part of what we do. And the only comment I would make on that is we can pretty much heat any space. We've also solved heating problems that no other system was able to do. I'm thinking more large warehouses, possibly where you almost trying to create a thermal envelope within a warehouse, so maybe 20% of the entire space, because radiant heat is directional. That is certainly achievable. So again, just restating the point, it's modular, so it's very simple, and it can be scaled to the requirement of a particular room, even in the hard to heat, where obviously the demand is higher. Full control in room by room and optimum comfort levels. And again, it's very hard to articulate, but the feedback consistently is this is just a really, really comfortable, nice heat to live with, rather than maybe sort of thermal swings high and low where people start to feel a little that the space is a little bit stuffy.
Yeah, Robert Llewellyn said when he appeared on a webinar not so long ago that his office, he's kitted his office out, his home garden office with infrared, and he's
heaters, yeah,
yeah.
He's got those.
He was saying how well it works in that instance.
Yeah, the image top left there, if you can see on the ceiling, so that's a new product we've introduced about 3 or 4 weeks ago called our crystal heater. Now 60 by 30 centimeters, it's a much higher surface temperature, so it's on the, there's no visible light from it, but it's certainly nothing you could touch compared to the white panels you can see to the right there. But you're getting an output of 600 watts or 1,000 watts from the same size heater, and you can chop it in flush with a plasterboard ceiling. So you've got a frame there, but that's getting quite a lot of interest, and it comes in white or black. The white will be available from June, but lots of developers and homeowners at the moment interested in that.
And then, so how does the system, if you were to go, well, presumably if you go with solar and infrared, then the solar is going to work with your hot water system. If you mentioned about some people, which is how I'd probably look at it with some of the rental properties, is you would migrate towards maybe using something like the panels, but at some beyond the point where you can no longer have a gas boiler from a hot water perspective, what solution look like there?
Well, that probably is the next slide, I think. So moving on, I think if we go on, so that's what we have branded as Hydronova, because we have got a smart control switch which we're including in the package. But what is behind that is the Sunamp Thermino. So we're not getting away from that. That's what the product is. We branded it Hydronova. So that is it's phase change material, a thermal battery. So you may well be aware of that already. Benefit being you're not storing big volumes of water. It reacts quickly when it's charging. It can be directly fed from solar to charge a 2.8 kilowatts element at the bottom of it. So you can charge it off peak or directly from solar, and you'll get so what we're selling are the equivalents of 150, 210 and 300 litre cylinder equivalents with the models. So what, in terms of weight, you've got to consider where they're going, because the smallest one is about 137 kilograms. And if you're taking the larger models upstairs, you need to look at how you're going to do that and where it's going to be stored, albeit it's probably an equivalent weight to having a large cylinder for water. But if you can put this on a ground floor in a utility room, a garage, or under the stairs, which is what I'm considering, then with a feed of water, you're needing just a cold water feed to it. And then that is enough with standard pressure to provide water throughout the rest of the property. Your sizing will depend on occupancy and number of bathrooms and kitchens and a number of people in there. But a neat solution and a different type of hot water solution.
Cool. Okay. Thank you. There any more slides?
Yeah, I've got a couple more.
I think, yeah, it's, well, Andy, I don't know who's next. It's me still, I think, but it's probably just showing some examples of the other spaces. I think we're doing a huge amount and being contacted by lots of companies for warehouse spaces at the moment who are looking to get away from gas in particular, and big space heaters. And so these are a couple of examples. One's a cafe area on the left, but quite poorly insulated concrete frame. The one is on the right is a typical warehouse space that we're looking to heat, and that's with ceramic element heaters, which we'll show in a minute for another heater type for churches that we've just launched. But my first question, as it should be in all of these spaces, is, okay, do you really need to be heating these environments in the full way you have done in the past? Because, yes, at the moment you've got that gas to electric kilowatt hour differential, so you're going to have to try and find ways, if you're wanting to heat whole spaces with electric, of offsetting that with solar and batteries, or some way of reducing that kilowatt hour price. But my first question is really, are you needing to heat all of that storage area in the same way that you have done with gas and other fossil fuel heating? If you can just keep it to task heating and spot heating of where people are at packing benches and other spaces, that's where your most efficiency is going to be. Use less. That's where your main win is going to be. So that's where we've got to start. And if we can't, then we're looking at other solutions between racking, and it will depend on heights of space and whether they're wanting to maintain a level of temperature across the whole environment for longer periods, or whether it's a fast warm up of spot heating for short periods of time. So there's a different approach.
And just that slide on the right, just to mention there, that was with this warehouse, 20% is where people are working. And they're basically analysing rock core, photographing it. So it's work that requires a certain amount of concentration. Their challenge was, we have this huge warehouse, 20% of it is where we need the comfort. They tried the propane blowers, boiler systems, every kind of heating system. They've just finished their 5th heating season, and the feedback is very consistent. We basically created a thermal envelope which is comfortable, and once we turn the heating off after usually 3 to 4 hours, even in the depths of winter, they still benefit from 2 to 3 hours of entire comfort before the temperature starts to feel less comfortable, simply because the concrete floor is radiating back. So it kind of proves over 5 heating systems that it's beyond concept. It's an effective way to approach warehouse heating.
Yeah, and it goes back to behavioural change, really, and your education piece, because you can't solve every problem, but you can solve a lot of problems by the sounds of it.
Yeah, we can. And it's quite often people are coming to us say, well, we've got a specialist process where we need to keep a certain level of furniture with glues, or things like that, where we've got people they can speak to, but the main focus of what we're trying to achieve is specifications for comfort heating of people and environments. That's where we're starting.
Yeah, cool. Okay, just got a couple of minutes left.
I'll just quickly rattle through this. It's just a few comments. So this was, again, I came from solar, looking for the heating equivalent of a solar module. So this is one of the first projects from 2015. So it's been around a while. So it was domestic refurbishment on the north coast of County Antrim in Northern Ireland. A 4 kilowatt solar edge system, an eddy to pick up surplus diverted onto the hot water cylinder. The customer was looking for an innovative, future-proofed heating system. So they visited the house here, actually saw infrared working alongside solar. The key message from this was, firstly, the ease of integration with the renovation program. It's one of the simplest things. The kit arrived when was promised, was installed by the site electrician, was set up literally in less than a day. But what was really interesting is this whole idea of operating at a lower. Now, Drew had done a very good job in terms of the insulation and the glazing. He was designing out the demand for heat. But even now, in the depths of winter, he is able to maintain absolute comfort throughout the house at just an 18-degree air temperature. And with the contribution of solar displacing some of the running costs, particularly in the spring and the autumn, the feedback has been very, very positive. But I say, it just demonstrates so much of what we're doing at the moment is we're almost defining technologies before we've sort of stepped back and said, well, what are we trying to achieve in terms of a ultra low carbon, zero carbon, and potentially net zero roadmap? My point consistently, based on sort of many years working in solar, is we should almost be defining the profile of the technology before we define the technology. So in both the case of the solar and the infrared, these are technologies that are relatively simple to design and install. Ultra low maintenance in terms of solar, zero maintenance in terms of the infrared, and a long operational lifespan. So if we are serious about net zero, that's kind of the profile that we need for the technology. The idea that we're servicing things that then need parts and that break down, you can't achieve net zero if you have that level of complexity. So this, even 7 or 8 years ago, was a very good opportunity to just demonstrate the concept of how essentially solid state technologies can be partnered, work very, very well together. As I say, upfront low capital cost, ultra low, if not zero running costs thereafter, and a long operational lifespan. And so this is end user feedback rather than our marketing team.
And some of the feedback from the developers that we've been speaking to about looking at infrared as options, and certainly some of the social housing groups, I think there is a concern with other systems on maintenance and callbacks from people using the systems and the complexity of controls around it, and then how to commission them, and then the ongoing servicing costs. So yeah, using infrared will remove a lot of that risk and concern for them.
Cool. No, that sounds good. Thank you very much. Yeah, I mean, what was pleased me about this one is, well, because we haven't done it before, there are lots of questions. So that people were asking the right sorts of questions. There's probably another session here to be had, actually. And I suppose it's just difficult for people to comprehend the experience, because they're just, if they haven't got one, it's difficult to understand the comfort that could be achieved. So I understand that the challenge here, but from sort of, not ticking the box is the wrong word, but in terms of providing a solution that will allow you to deliver on a more of a low carbon scenario, yeah, it's interesting. So,
and our successes, Simon, have been, in spite of the legislation, which is against us. So it's been, it's end user experience and customers pushing us to say, we want, why is this not getting recognised more? And I think the challenge is government needing to analyse and be clear for consumers on what these different technologies offer, but quickly enough to address the climate emergency that we've got. So that's and this is a solution that's available now and can be rolled out at scale without retraining of lots of different installers, because there's not a specialist approach. That electrician installation market is there to carry this out. So, that's where we're pushing the focus with the people we're speaking to, but they've got to go through various hoops to make sure they've gone through all the technologies, understand the physics behind it, and what claims are being made by parts of the industry to make sure they've got the confidence to push that to the consumer market.
No, and I think the point there around the skills is an important one as well. I mean, it's what Nigel was saying from Ilka Homes in terms of, the way their modern methods of construction. They've created a factory. They have people from call centers, nurses, building effectively houses without but just trained from scratch. They're not having to upskill.
No.
And anyone, not anyone can do it, but obviously once they've been trained, anyone can do it. So you are helping. There's less of a drain on the skills pressure here, and we've got David Pierpoint from the Retrofit Academy speaking in a couple of weeks or so. It's a massive challenge. So yeah, and anything that enables people to swap out from fossil fueled central heating systems to climate friendly heating systems without too much hassle is people pay their money and they make their choice. But thank you for providing summary and enlightening us when it comes to infrared heating. It's definitely been worthwhile listening to, and I'm sure we'll do another session because I think people will missed out on this. I'll upload this to Meshwork as suggested. I'll upload the presentation as well, and please follow Andy and Matt on LinkedIn for any by way of saying thank you, and also just to stay in touch and understand what's going on in that particular industry. So no, thanks guys for taking the time, and thank you everyone else for attending, and I'll see you on the call next week. Cheers guys.
Thank you.
Thanks all.
Thanks.